I'm resuming. I have two purposes for today. Purpose number one is I wanted to throw this example out to you because we haven't seen one like this before, and this will also give us a chance to look at graphs. So purpose number one really is to show you what does it look like when I have to make the graph, not hard. And then purpose number two, you'll see in example number two. So let's knock this one out real quick. This is what you did a whole assignment on Thursday, so you should have no issues with this. First off, what's A? Yeah, it's okay that we're a little rusty. What's B? One is right. What is H? Zero is correct. What is K? X. Good. And what is C? I can tell you, like, when I started my assignment, because I do your homework with you most of the time, I wrote the formula down up here. So you should have that handy too. So you're going to want to remember that C squared, or C, is always equal to the square root of A squared minus B squared. Yeah, it's root 48, which is 4 root 3. That'll change, by the way. You seniors probably won't get to sniff this, but juniors will get to hyperbolas after this. And with hyperbolas, that equation up there, the purple thing changes a little bit. But for ellipses, it always works like that. Any questions about where any of those 5 numbers came from? All right, then let's go down and list all of our parts and pieces out. So in order, I really don't care what order you do them in, but the center is where? Mm-hmm. And the next thing I like to do is I've just been cheating. You notice from my answer key, I'm getting tired of writing length of major axis. So I just call long. What's long? 14 is correct. I put long as at, and that's supposed to be an equal sign. So what is short? 2. And this is where in order, like to go vertices, co-vertices, foci. I'm not going to make you keep writing the focal length because like we already have it up here. So I caught myself just saying, I don't, why restate it? So it's already there. So I took that out of the directions. Let's go with vertices. First thing I would do is try to decide, is this a long horizontal ellipse or a tall vertical ellipse? It's a long one because a squared is under the x. So if it's going to be, if the power number is under the x, it's a stretchy sideways. So it's sometimes worth it to just make a little sketch over here, just to remind yourself about which coordinates change when I do vertices and co-vertices and foci. So in a sideways ellipse like this, it's the x that gets changed when we go to find the vertices left and right. So the y coordinate will not change. So I could put vertices at something 6 and something 6, right? Yeah. So 7 and -7. That's correct. With the co-vertices, since it's a long ellipse, the short vertices are going to be y changing. So this time, when I make my points, it's my x that's not going to change. So the 0 is going to stay consistent this time. How far up and down do we go? 7 and 5, right? We're going up 1 or down 1. That's that b value. So we're going to go up to 7 or down. And then the last bit of this is just the foci. And again, the x is what changes, so the y can stay at 6. If you haven't caught on to that yet, it really, really helps. Like huge off the charts helps to copy down the coordinate that's not going to change. I think. So we're going to lead from the center at 0. How far to the right are we going to go to get our first focus? 4 root 3, correct. And then to the left, negative root 3. Right. So me from last week had you write the focal length, but I think you all clearly understand that it's like, it's right there. It's C, so no need to express that again. All right, so what's new today is making a graph, and you guys have all this written down, right? So I'm going to make a new page and bring in a graph. Would you guys like a piece of graph paper? Because if so, Brooklyn would be happy to give everyone a piece. I have a piece, but it's 8 graphs that goes with 8 problems in your homework. So um, that's fine. Sure. Do I have enough? Oh. Oh, I'm recording. Oh. Oh. Leave it in. Okay. It's not like you cussed or anything. Right? I just screamed. Not that one. We need extra. Did you just hear, like, was there like a goblin in the shuffleboard? Yeah. Well, maybe before the next presidential election, Brooklyn's going to get you guys all a piece of graph paper. But listen, I really don't care what kind, just not the quadrant 1 graphs, just anything is fine. Maybe you guys should just go help yourself if you want one, because this honestly might be like mid-June before. Huzzah. Yeah. They just like it. He sneezed and stop. No, Brady James, that is crazy. I'm just like, so you guys have all of the information, so I'm going to be relying on you, since I guess I could just go back and forth. Like, that seems like a pretty reasonable expectation. So the first thing we should all do, because I've never had you graph one of these before, is we're going to all go plot the center, which is at 0, 6. So I'm going to go to the point 0, 6, and I'm going to make a dot. Now, the order that you do this in from here is honestly really not that important, and it's really not that difficult. As you found with parabolas, I think we're still good. Graphing sometimes becomes the hardest part, right? Like just trying to not make it look like a 2-year-old did it. So let's graph our vertices next. So the vertices are across at 7, 6 and way to the left at negative 7, 6. So 1, 2, 3, 4, 5, 6, 7, 6. So my vertices I will make purple. And then really the last connecting piece, unless you want to go find more points, which you don't need to do, is going to be the co-vertices. And the co-vertices are just one up and one down from the vertex. So this will be a super slim ellipse. So if I go up 1 from the center and down 1, I get those. And then we have the unenviable task of trying to sketch this, which may not be a good first problem to try to do this on because it's so elongated. So apologies for that. So it's, you know what, that's really, really bad. And I'm just going to leave it like that. So is, is it, how's yours? Yeah, that's a rough first one. I probably should have thought that through. Those skinny ones, just like parabolas, are the hardest to graph. Anyways, I do want you to also graph the foci. And so when we make a graph, we should include the center, all 4 types of vertices, and the 2 foci, and then we do our best to sketch it. But the foci are at 4 root 5s, right? So what we need for that is a calculator. Say it again. Oh, sorry, 4 root 3. So what I want to know is like if you ask someone, hey, make me a mark at 4 root 3, they're going to look at you like you got two heads. But if you just go in your calculator and type in 4 times the square root of 3, then you'll get about 6.9. And that's good enough for what we're trying to accomplish here. And so these foci are actually almost pretty close all the way out there. So in a case like this, if you didn't even graph them, I don't think I'd be upset. But if I were to like zoom in, which if I'd known this, I would have made my graph better, but the foci are way, way out there, right? So do you have any questions just about that process? The next problem has a different purpose. I just wanted this one to be an introduction to, I expect you to be able to make a graph. So we find all this good information, we might as well put it to use. All right, so let's do another one. And you might spot right away what's wrong, you might not, but I've been holding out on you, avoiding this until today. So does anyone see the Houston, we have a problem sort of thing? Hmm? Yep. So we're going to have a whole lot of irrational numbers going on here, just for the record. And I wanted you to have some exposure to this. I think of the 8 problems on your next assignment, I think 3 of them are like this. And it's nothing that you can't handle. It's just that I would be remiss if we didn't, again, have some exposure to this. So let's get going down the list. It's always the list. What's A? Yeah, that's correct. A is root 30. Yeah, bless you. And as you've seen, if you have a simplifiable root, like on the last problem, root 48, you need to break down, but root 30 is dead. It's only factors do us no good. What's B? Root 10. Very good. What's H? What's K? 0. Because the Y is like Y minus 0, right? And then C? Yes, I really appreciate that you took your time and calculated the whole thing out. The answer is indeed 2 root 5. So the trick to finding C is, yeah, you got a formula, but really just take big minus little. 30 minus 10 is 20. And then you take the square root of that. And the root 20 is root 4, root 5, 2, root 5. Well played over there, Brady. Good. So any questions about A through C, any of those? And is this a horizontal or a vertical ellipse? It's a vertical ellipse because the power number is under the Y. And so, again, always a good idea. Just nothing formal, just making a quick sketch keeps us focused, sorry, unintentional pun, on which coordinates stay and which ones change. So, all right, let's do this. Center. -1, 0 is perfect. I think length of major axis is next, right? What's the long? Yeah, it's 2 root 30. Well played. So again, I'm trying to get us out of our comfort zone because we really like it when the long axis is like, ooh, 20 or 12, but here it is what it is. What's the short axis? 2 root 10. Nice. All right, so at this point, basically everything now, if you haven't figured this out yet, maybe today's your day. Everything that we do now revolves around the point -1, 0. The question is, when I leave there, am I going out to find my foci? Am I going on a long journey to find the vertices? Am I going on a short journey to find the co-vertices? But you need to just start everything there. That's the key. All right, so let's do vertices. And because it's a vertical ellipse, the vertices are going to be up and down, right? So who's changing? The Y is. So we know both of our vertices are going to start with -1 something, knowing that the X doesn't change. Did you put that thing like in your bag or pocket or something? I think did you just get vibrated again? Did you guys not hear it?
I wouldn't have.
Oh, that might be me. My bad. Um, so how far up do we go?
Uh, 30.
Root 30 upwards. Good. And we're starting at 0, which is nice. So we don't have to do any plus or minus stuff. So root 30 is the high vertex, and then down. So negative root 30 is the low vertex. And when we have to go graph this in a bit, we already know that root 30 is probably darn near about 5.5. We get math well enough to know it's about smack dab between 25 and 36. So we can expect that. Our co-vertices are left and right because it's a tall ellipse. And how far left and right? Well, first off, who's changing or who's staying is what I should say.
Why?
The y stays the same, right? So this time I can leave my 0 the same. Did I say that right? Yeah. So the y coordinate stays. It's the x that's going to be the shifter. And how far left and right do we go? Root 10. So what's my, I don't care if we go left or right first. Let's go left first. What's my left covertex? It already starts at -1 to the left, and we have to go minus root 10 more. So we can't get away with the simplicity that we did with the main vertices because the main vertices started at 0. But when you start at a number, you have to express it as an addition or a subtraction problem. And so what's my covertex on the, are you raising your hand, bro? Oh, what's our covertex on the right going to be? Correct. I wanted to give you a taste of this when it's just irrational numbers everywhere. And comically enough, there's one on your assignment where A and B are irrational, but C works himself out then to be the rational one, which is sort of a role reversal. It happens pretty early in the assignment. Last up is the foci. And again, for the foci, because it's a vertical ellipse, it's the y that changes. The x stays the same. So I can just do -1 blank and -1 blank. But I made my spaces too big because, again, the y coordinate that we're starting at is a 0. And when you modify a 0, you don't need any plus or minus, right? So how far up do we go to get, say, to the upper focus?
5.
Yeah, you guys are good. And then the lower?
Yeah, yeah.
All right, so let's go make one more sketch and then I'll get you to work. All right. New page. Mr. Graphy. So I'll just try to go back and forth. So let's start with center. Center's at -1, 0. So we're going to make our first dot there. And calculators are going to be of massive assistance to us here. So it's a vertical ellipse. So let's go find our major vertices first. And they are going to be above at root 30. And are we all at peace if we just call that 5.5? It's about what it is, right? So we can go up about 5.5 and then down about 5.5 to get to the vertices. There's really no sense in being too accurate with it because, like on a piece of graph paper, I mean, really, it's going to look about the same either way. So we're going to go up 1, 2, 3, 4, 5 and change. So there's a vertex and there's another vertex. Okay. And then to find the minor axis vertices or the co-vertices, we're going to go right and left, but only 3 and change, like 3 and just a little bit of change, right? Because we're just a skosh over the square root of 9. So we're just going to begin our journey from the vertex and travel left 3 and change and then right 3 and change. So it should be not quite imperceptibly, but almost imperceptibly past.
Are we adding, subtracting?
Are we what?
Are we adding and subtracting, well, subtracting one of both of these? Because it's,
Well, the negative one that you see in the name is it's like the starting point is already accounted for. So like when you, are you I assume you're talking about that. Yeah, so like it's already starting at -1. That's what this is. So we're just moving from that location left and right, root 10. Does that make sense, Brady?
Mhm.
Okay. And then let's find the foci. And the foci are going to be above and below a distance of 2 root 5. And that ought to be, I'm guessing, right around almost 5. 4.5. So I was off by a little bit. So that would have been bad. So 4.5 is good enough. So we're going to go up 4.5. I guess I'll use green. 1, 2, 3, 4.5. And it's just a little under 4.5. And then you have everything you need. You have your vertices, your minor vertices, your foci, your center, and then you again get to try to make a sketch. I just am going full send on this. I'm not going to sit here and make this take too long. Oh God, that right. It was doing okay until I made that hard right turn at Albuquerque there. There. Okay. It's not great. That's not winning any awards. It looks like a lemon or something, but it'll do. So, you guys have any questions about that? So the two main missions for the day were to one, get you looking at making your own graphs now, and two, get you familiar with the fact that sometimes a lot of the numbers are going to be irrational, but we're tough. Like we're not scared of irrational numbers. We're not scared of root tens and stuff like that. Yeah, cool. Oh, did you have a? Oh, all right. So I'm going to